Hi and hello, I am Athena Pondian here. Welcome to the control system for the Biomedical Engineers classroom once again. Today we are going to see the last topic of our first unit, that is conversion of block diagram into the signal flow graph. How we can able to convert the block diagram reduction into the signal flow graph, and how we can able to execute, what is the process and what is the procedure we need to apply, all the things we are going to discuss today. Come, let me start the class now. See, signal flow graph. Of course, we know that Mason's gain formula. Using the Mason's gain formula, we can able to determine the transfer function very easily. It involves only the 6 steps to determine the transfer function. Rather, in the block diagram reduction, we are using so many block diagram rules to apply over it, and we just got confused to determine the transfer function. So, for overcoming this particular disadvantages, the Mason's introduced the signal flow graphs that we already discussed about it. So now, how we can able to determine this particular block diagram reduction, and how we can able to change this block diagram into the signal flow graph. That is the thing we are going to discuss today. So of course you know that what is the purpose of changing, because block diagram reduction gives more amount of time. At the same time it got confused. The persons got confused once you are solving this block diagram reduction. For overcoming this particular disadvantage, we go for the signal flow graph. So that is what we are need in the conversion of this block diagram into the signal flow graph. So what is the steps? How we can able to convert the block diagram into the signal flow graph? Okay, come. So this is the way of representation of the system. That is, it is the way is called as a block diagram. Okay. So this block diagram representation is enough for calculating the transfer function by applying block diagram reduction rule. But many of them got confused by reducing this particular block diagram by applying block diagram reduction rule. We are supposed to change this block diagram into the signal flow graph, because signal flow graph is very comfortable for determining the transfer function. Within 6 steps, we can able to determine the transfer function using Mason's gain formula. Okay, so that is what we need to convert this block diagram into the signal flow graph. What is the steps we need to do is, see, just listen. All the summing point, branch point, and elements, that is forward path elements and the feedback elements, output, input, all the thing you need to note. See, you just fix a number for each and everything. You just look this particular forward path only. Okay, please look this particular forward path only. That is from starting to ending. No need of any forward path. You just look one forward path that starts from R of S, end towards the C of S. That is input to output. Just look at. Then fix a number. Fix a number is there is any meeting of branch point, summing point, elements, feedback elements, whatever it may be. Is there is any meeting over there in this particular C of S, R of S line, just put a number. Okay, including input and output. What I am saying is, just give a number to the input as 1. Then the next meeting is summing point here in this forward path. Then put a number 2 here. Okay, then the next element G of 1. Then fix an element number 3. Then the branch point is there. Then put 4. Then the next element, put number 5. And the next we have summing point. Put number 6. Then the next element, it is 7. Then the next, this particular point is 8. Then this element, 9. Then this particular element, 10. Don't confuse that. Here it is connected in the one line. That is what I am fixing only 10. No problem. Okay. Then it is 11. So this is the first step you need to do. Just look the straight line from R of S to C of S. What are all the things that is connected? What are all the things that is interrupt in this particular line? Just fix a number. Whether it may be a branch point or summing point, whether input or output, or elements, feedback elements, whatever it may be. Just fix a number like this. Okay. Then what is the thing? Next step is, just make a straight line. How many numbers? 1 to 11 we are putting. Just frame 1 to 11 like here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Here 1 is an input. Here it is 1 is an input. That is R of S. Then this 2 is coming from where it is coming from? From 10 it is coming to 2. In between that, H2 is there. The H2 is connected to minus. So, the 10 is connected to 2. Please remember, 2 is not connected to 10. The 10 is connected to 2. In between that, H2 is there. And most importantly, this particular summing point indicates minus sign. So we are just connecting from 2, 10 to 2. In between that, we have minus H2. Hope you remember. Okay, then this particular third, we can able to fix this third number. We already know that the indication of elements in the signal flow graph is arrow mark. Then put G1. Then the next is branch point 4. This 4 is connected to 10 again. In between that, G5 is there. There is no positive, negative. You just indicated as positive elements. So 4 is connected to 10. This 4 is connected to 10 again. In between that, the element indication is in the arrow mark. It is G5. Hope you understand. Then come to this particular 5 is G2. Then indicated as G2. Then look 6. 6 is a summing point connection. That is 8 is connected to 6. In between that, H1 is there. Minus sign is there. So 8 to 6 connection in the minus H1. 8 to 6 connection. In between that, minus H1 is there. Please don't confuse. Don't need to put any arrow mark indication here in this part, because arrow mark indication is especially for element. Okay, element and feedback element. Then this 7 indication of G3. This 7 is indication of G3. Then 8. 8 is connected to 6. We already framed. Okay. Then this particular 9 is indicated as G4. Then 10. We already made the connection between 2 to 4. That is 2 and to 4. We already made it. Then 11 is output. That's all. We are just converting this particular block diagram into the signal flow graph successfully. Okay, most important thing is you need to put minus sign here. If in case in the summing point you are getting the negative feedback path, then the minus indication is very important. Most of them are done a mistake in here itself. Okay, and please make a number properly, and the connection made is very important, because 2 to 10 and 10 to 2, that is the word make a difference. 2 to 10 indicates that the arrow mark indication is going like this. 10 to 2, the arrow mark indication is like this. The word itself says that. So please remind in the mind itself. We just keep on telling in the mind. 10 to 2, not from 2 to 10. Okay. So that's what I'm putting. 2 to 10 to 2 indication is mark and minus H2. If your mind says that 2 to 10 connection like that, then your mind unfortunately put 2 to 10 connection. That is what you need to remember. The connections made is very important. Where it is come and where it is ends. That is the thing very important. So once you are framing all this thing, the conversion is made successfully. Then after that, you are well known about it. That is the 5 steps you need to follow. That is the first step is forward path. Determine the forward path. In that, we are determining number of forward path, and that is a forward path gain. And the second step, we need to determine the individual loop. There is how many individual loops are there and what is the gain of that. And the third step, we need to determine non-touching loop. A pair of non-touching loop gain we need to calculate. And the fourth step, calculation of del. And the fifth step, calculation of del K. And the sixth step, we need to apply the Mason's gain formula. Capital T is equal to 1 by del into summation del K Pk. Okay, so this is what we need to convert. Hope you understand. We already know that we are familiar to solve this particular signal flow graph. Okay, so that's all about the today's class. We are just convert this block diagram reduction into the signal flow graph. Hope you understand the first unit also. So keep on, we are go through all these topics under the first unit. If you have any doubts, you are just please arise through the classroom itself, because we are just hold the first unit today. Tomorrow itself we are going to start the second unit, that is time response analysis. Thank you very much.